first tape in a 3-tape series on beginning algebra. As you watch the tape series, keep in mind two things. Number one, algebra is arithmetic. Now, for some of you, this is a first exposure to algebra. Algebra is arithmetic. And you know a lot more about arithmetic than you possibly think you do. As you watch the tape, you'll see that many of the things that you experienced in arithmetic, you're going to experience in algebra. You're going to learn the algebra basically the same way you learned the arithmetic. Second thing, the key to your ability to remember and then use the algebra you're going to see is practice. I think you'll understand after watching the tape what's going on. The key to your ability to use this later is the time you spend practicing the techniques that you're going to see on this tape. Now, since algebra is arithmetic, we should get some clues as to how to learn algebra by looking at some parts of arithmetic. So let's look at the number 235. If you'll think back to your exposure to arithmetic, at the very outset, and this may have been quite a while ago for you, at the very outset you learned the meanings of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then you learned a counting pattern. One of the numbers in the counting pattern was this, 235. You had to come to grips with the meaning of that number. And you did this. You learned that this was 2 times 100 plus 3 times 10 plus 5 times 1. Or you may have even broken it down further and learned this as 2 times 10 squared plus 3 times 10 plus 5 times 1. But regardless of how you learned it, you learned the meaning of a number. Having learned the meanings of the numbers, having learned to count, then you proceeded to work on the 4 basic operations: adding, subtracting, multiplying, and dividing. Well, this is exactly what we're going to be doing. We're going to talk about the meanings of the numbers that we're going to deal with in algebra, and then we're going to talk about the 4 basic operations: add, subtract, multiply, and divide. This first tape is given to defining the meaning of the algebraic numbers we'll use and in learning how to add and subtract. Now, let's look at one of these algebraic numbers that we're going to be dealing with. This is read x to the 3rd power. We have some words that we use to describe this. X is called a variable. And the 3 is called an exponent. I'm fairly confident that you've seen this before. This is a shorthand notation, a quick way to write a more complicated expression. This small number written in the upper right-hand corner that we call an exponent simply tells me how many times I'm going to use x as a factor. This means x times x times x. I think you can see that this is a very powerful notation. For instance, if we had a 10 right here, this is read x to the 10th power. It's an abbreviated form for x times x times x times x times x 10 times. And if we took the actual time to write this out, it would be very time-consuming and very cumbersome. So this notation x to the 10th represents the same thing. Now, I've also given x a name. I've called it a variable. A variable. What on earth is a variable? Well, if you're looking at your notes that accompany this tape, variable is defined to be a symbol used to represent a number in a set of numbers, and that set of numbers contains more than one member. Now that may seem to be a little bit difficult to understand. But let me give you an example. Suppose I have a collection of numbers, 1, 2, 3, 4, 5. And I make this statement to you. X is a number in this collection. X is a number in this collection. What is X equal to? What is X? Well, you might say, well, X could be 1 or 2 or possibly 3 or even 4 or 5. And that's right. X could be any one of these. The value we assign to this symbol can vary. Hence the name variable. The value we assign to this symbol, X, can vary. So we call this a variable. Now, a variable is a symbol used to represent a number in this set. We didn't have to use X. We could have used Y. We could have used Z. We can use any number, or pardon me, any letter we want. Sometimes we don't use a letter. Early in your mathematical career, you probably used this as a variable, a little box. For instance, if we had box plus 2 is equal to 3, this box stands for a number. We're not sure what we want to use at this time for that number. So this is a variable. It's a symbol that is used to represent a number, and we're not sure what we want to use for that number. Now, the type of number we're going to see in algebra is composed of variables, exponents, sometimes more than one variable, sometimes more than one exponent. So let's move right over here. We have a number that we might wish to deal with. 5x to the second power, 5x squared. The x is a variable. The 2 is an exponent. We have a name which we apply to this number. If you're listening closely, you'll find that these names are very descriptive. We call this number a coefficient. Coefficient. This is the coefficient for x squared. Coefficient simply means that the number accompanies x squared. So, if we're going to use this type of number, one of the things we're interested in being able to do before this tape is done, we'd like to be able to add numbers that look like this to other numbers. Before we do this, though, let me try to expand your vocabulary just a bit. This could be another number that we would deal with. 2x squared plus 5y plus 3xy squared. We have two variables here. We have x and y. We don't know what x and y represent right now. If you were to tell me what x represents and what y represents, I could replace x and y with those numbers and condense this into a nice, simple number. But without the knowledge of what x and y represent, this is about as good as I can do. X squared has a coefficient of 2. Y has a coefficient of 5. XY squared has a coefficient of 3. Now, we have names for these numbers that we use in algebra. And I'm not telling you that these names are terribly important. I'd like you to know them because I'll use them some on this videotape, and also in your reading you may encounter these words. And they're again very descriptive. We have the word monomial. Monomial. Now, if you'll take the time to look at this word carefully, the prefix is mono. It means one. This is a one-termed expression. The example that I have here on the board, 5x squared, is an example of a monomial. This is said to have one term. You might look at that and say, well, now I believe what you say, but I don't quite understand it. There's a 5 here and there's an x squared here. And you say there's just one term. What do you mean by a term? Well, that's a good question, and that's something we'll have to come to deal with. If I have this expression, 5x squared plus y, this expression has two terms in it. The key to identifying when you change from one term to another term is the addition symbol or the subtraction symbol. Whenever you see the addition symbol or the subtraction symbol, then this should be the key to telling you that you're changing from one term to another term. 5x squared means 5 times x squared. This would be considered as a single term. This would be considered as a single term. So this expression would have two terms in it, and I don't think it stretches your imagination too much. I would guess you could probably rather accurately find a name for this. The name we use for it is binomial. The prefix bi means two. So a binomial would be a two-termed expression. Now let's practice with this for just a moment. Here's another example of one of these numbers we might see. X to the third power plus 5xy minus 4y to the second power. One thing we need to be able to do, count the number of terms present. One term right here, you see the addition sign, that indicates I'm changing to another term. 5x squared, xy would be a second term. Here you see the subtraction sign, that indicates I'm changing to another term. 4y squared. This has three terms in it. What do you think you would name a number that has three terms? Well, the prefix tri means three, so this is a trinomial. A trinomial, a three-termed expression. Monomial would be a one-termed expression, binomial, two-termed expression, trinomial, three-termed expression. The x, the y are variables. The coefficient for x to the third power, even though it isn't written, is 1. The coefficient, the number that accompanies x to the third power, is 1. Now, most of the time we don't write this, but it's there nonetheless. 1 is a very special number to us. When you multiply 1 times another number, you don't change that number. 1 times 3 is 3. 1 times 10 would be 10. So 1 times x to the third power would still be x to the third power. Now, as we go through this tape, you may find it to be to your advantage, understanding-wise, to write in this 1. If you do, that's fine. If in your textbook you see it there, that's great. If you see something like this with it not there, that still means the same thing. The coefficient here is 1. The coefficient for the term having the variables xy is 5. Coefficient here would be 4. 4y squared. The variable would be y. Now, one objective, and it's going to be important to us, you should be able to count the terms in an expression. We'll exaggerate here and put in a very complicated looking number, but after we take it apart, it's really not that complicated. How many terms are there? Well, let's see. 5 times x times y to the third power, that would all be one term. Here's our key. We see addition, so this means we're changing to a different term. I don't see any more addition or subtraction, so evidently all of this, 46 times x to the 10th, y to the 14th, z to the 84th, would all make up the second term. This is a two-termed expression. This is a binomial. There are three variables involved, x, y, and z. When you see things like this, 5x y to the third power, I'm hoping that you have some inkling as to what this means. Y to the third power means y times y times y. And when you see x to the 10th, that means x times x times x. How many times? Well, 10 times. Now that would be a very lengthy expression. Y to the 14th, that means y times y times y times y, 14 times. Z to the 84th would be z times z times z times z times z, 84 times. Now, a word that you will see, and a word that I've already used on the videotape, is this, polynomial. Polynomial. The prefix poly means many, so technically this is a many-termed expression. Now we use this word as really a catch-all type of word. The topic of this tape is the addition and subtraction of polynomials. Now a polynomial could be a one-termed expression or a two-termed expression or a three-termed expression or a 10-termed expression. Polynomial. Numbers that involve variables. Now there's a little more to this definition than I'm giving you right now, but for the purpose of this tape, this is going to be sufficient. Now, let's move on to addition. Now, in order to talk about addition, if algebra is arithmetic, we should learn something about adding algebraic expressions by studying what we did when we added numbers in arithmetic. If we wanted to add 235 to 324, we write the numbers one over the other and we add. We say 5 plus 4 would be 9, 3 plus 2 would be 5, 2 plus 3 would be 5. Now this is our process for adding. But if we take that process apart and look at it a little more carefully, we're going to see something very important to us. Number one, why did we write these numbers one above the other? Think back to the meaning of these numbers. The top number meant 2 groups of 100 plus 3 groups of 10 plus 5 groups of 1. And the second number meant 3 groups of 100 plus 2 groups of 10 plus 4 groups of 1. And the rule you learned in arithmetic was you may only add likes to likes. The reason you stack these numbers would be so that the ones digit would be added to the ones digit, the tens digit added to the tens digit, the 100s digit added to the 100s digit. You're adding likes to likes. Here, when you add 5 ones to 4 more ones, you will get 9 ones. When you add 3 tens to 2 more tens, you'll get 5 tens. When you add 2 100s to 3 more 100s, you'll get 5 100s. You add likes to likes. If you have 5 apples and you add that to 2 more apples, you'll have 7 apples. If you have 5 apples and you add that to 3 oranges, what would you have? Well, you're not adding likes to likes. It's difficult to add those two quantities that aren't alike. Now that's the key to everything we're going to do in algebra. It's the key in arithmetic. It's still the key in algebra. On your worksheet, labeled as example number 1, you have 3x added to 5x. Now you could write this just exactly as we did a moment ago. You could stack these. You're adding x's. A moment ago we were adding 1s or 10s or 100s. Now you're adding x's. If you have 3 x's and you add to this 5 x's, then you'll have 8 x's. The rule is you add likes to likes. You add the coefficients if the variables are the same. Now, move in your notes to example number 2. Example number 2, we're asked to add these two numbers together. If you wanted to review just a moment, this would be a three-termed expression, a trinomial if you wish. This number has three terms. This number also has three terms. So we're adding these two numbers together. The one rule we have, you may only add likes to likes. So if you wish to go back and use your knowledge of arithmetic, you could. In arithmetic, you normally rewrite the problem. You stack one number on top of the other. You stack these in such a way that the like terms are added to like terms. So if I'm rewriting this, underneath the 5x squared, I would write 7x squared. Underneath the 4x, I would write 2x. And underneath the 3, I would write 5. These two are alike. I add them, and I get 8. These two, the variable arrangement in each of these two is the same. Each of them has x. If I have 4 x's and I add to that 2 x's, I will get 6 x's. These two are like terms. The variable arrangements are the same. So if I add 5x squareds to 7x squareds, I would get 12 of these x squareds. Now that's all there is to addition. You say, well, gee, that's not too hard. That's right. That's not too hard. That's very easy. The only thing you needed was a knowledge of arithmetic. In arithmetic, you add likes to likes. In algebra, you add likes to likes. That's all there is to it. Let's try another example. In your notes, this is labeled as example number 3. Here we're asked to add two numbers together. And again, to get a little extra practice, we note that this first number has three terms. 3xy is one term, 5x is another term, 2 is a third term. The x and y's are variables. The coefficient for xy is 3. The coefficient for x is 5. The second number has only two terms. Now my job is to add. So I can rewrite this as 3xy plus 5x plus 2. If I'm going to stack these numbers, underneath the 3xy, I'll put 2xy. And underneath the 5x, I'll put minus 4x. I add. Now, I didn't have a term like the 2. If you wish to think of this as being a 0 right here, that's fine. You're adding 2 to the 0, and you'll get 2. 2 plus 0 is 2. 5x added to a minus 4x. The terms are alike. Each of them has the variable x. So I simply add the coefficients. 5 added to a negative 4 would be a positive 1. So you could write this as plus 1x. That's fine if you leave that 1 right there. I don't have any quarrel with that at all. If you wish to leave it off, that's fine. It means the same thing. 1 times x is still x. So you do as you like about writing the 1. The further you go in your literature, you'll find that the authors of your textbooks will not write that 1. But if it helps you understand, leave it there. These two terms are alike. 3xy, 2xy. The variable arrangements are exactly the same. So we add 3 of these added to 2 of these would be 5 of those xy's. So the algorithm, the process for adding that you used in arithmetic, still works algebraically. Now let's slide back over here to example number 2. We don't have to use this We don't have to use this particular form. If you want to look at these two numbers and say to yourself, this term is like this term, that's fine. You could say, I'm going to add 5x squared to 7x squared. Those two are alike, therefore I can add them together. Also looking at these two, you see that you have a 4x and a 2x. If you wish to add those together, that's fine. You're adding likes to likes. Noticing we have two more terms that are alike. We have a 3 and a 5. We can add those two together. Sometimes we use symbols which help us organize this better in our mind. These are called parentheses. We're going to add those two together, so we put parentheses around them, indicating that we intend to add those two together. We're going to put parentheses around these two, indicating that those two will be added. Put parentheses around these two, indicating that these two will be added. The result does not change. 5x squareds added to 7x squareds would be 12x squareds. 4x added to 2x would be 6x. And 3 plus 5 would be 8. That's the same answer we had before. You choose the form that you understand better. If it's easier for you to use the addition algorithm from arithmetic, then use it. Or if you prefer this, use it. I think the further you go into the course, you'll become partial to this. I think you'll be doing it this way. Okay, now, look at example number 3. We talked about it a moment ago. Let me change it just a little bit. This is a good example of something that could happen to you later on. Same problem, almost. I'm going to make one minor change in it. We have 3xy plus 5x plus 2, and we want to add this to 2yx minus 4x. Now the only thing you must remember, I've got to add likes to likes. And of course, a problem arises. We look at this, 3xy, and we look at this, 2yx. Are those like terms? Do those have the same meaning? Now keep in mind, algebra is arithmetic. The answer to your question lies in your knowledge of arithmetic. In arithmetic, 2 times 3, that's 6. 3 times 2, that's also 6. And you say, well, gee, everybody knows that. That's right. You've learned that when you multiply, it does not make any difference in which order you multiply. 2 times 3, 3 times 2. Same thing. X and Y are numbers. X stands for some number. We don't know what it is right now. Y stands for some number. We don't know what it is. How does X times Y compare with Y times X? Well, because these two are numbers and it doesn't make any difference in what order you multiply, those are the same. Those are the same. 3xy and 2yx are like terms because x times y means the same thing as y times x. The understanding of this is not based on some mystical rule in algebra. That goes back to what you know about basic arithmetic. So, if we add 3xy plus 5x plus 2, I can put under this 2yx minus 4x. We add likes to likes. Don't have anything to which we can add the 2. Here when we add, we get plus 1x, or simply x. What do we get here? 3 plus 2 is 5. Everyone knows that, but what do you write down? Whatever suits you. X times y, that's fine. Y times x, that means the same thing. Now you could use your other algorithm, your other method on this, if you simply looked at these two and said, I'm going to add these two like terms together, 3xy plus 2yx, I'm going to add these two like terms together, 5x added to minus 4x, and I don't have anything to add to the two. You'd get the same thing. 5 either xy or yx plus 5 added to a negative 4 is 1. 1x plus 2. Could I add these two together? No, they're not like terms. That's like adding 5 oranges to 1 apple. Could I add these two together? No, they're not like terms. This is the best I can do unless you want to tell me what to use for x and y. If you tell me what to use for x and y, I could then add all these together. Now, let's move on to some other examples. Example number 4. We're asked to add two numbers. This is a trinomial, 1, 2, 3 terms. This is a trinomial, 1, 2, 3 terms. We could add using the process from arithmetic. We could stack these. If I stack them, likes above likes. So below minus 8x squared, 5x squared. Below 2y, I would put 3y. Below negative 6, I would put 4. Adding, minus 2. 5y. Minus 3x squared. As long as these are like terms, all I have to do is add the coefficients. The other process, which I think will gain popularity with you as we go along, look at the two numbers. Pick out the like terms, minus 8x squared and 5x squared. To this, add, pick out the like terms, 2y, 3y. Pick out the like terms, minus 6 and 4. And then add, minus 3x squared plus 5y minus 2. Exactly the same answer. No difference. Okay, let's move on to example number 5. Example number 5 is again an addition problem. We're wanting to add this number to this number. The rule, you add likes to likes. So you look through the numbers and try to find terms that are alike. 5x squared y is the same term, the same type of term as 4x squared y. The variables have the same arrangement. Keep in mind, this means x times y. And this means x times y. Those two variable arrangements are the same. So I have 5x squared y plus 4x squared y. Now, as a practical matter, and this may be something you'd want to do, it may not. When the numbers are large, such as these two, if you want to keep track of where you are, you might lightly scratch through these numbers that you've considered. In other words, you've already determined that these two are alike. Scratch them off so that you won't have to look at them anymore. Look again. 8xy and 5xy. Like terms. We can add those together. Scratch them off. These last two terms happen also to be alike. They each have xy squared as the variable. X times y, this also is x times y times y. So this would be 9xy squared plus 11xy squared. Adding we get 9x squared y plus 13xy plus 20xy squared. No more addition is possible. These three terms are not alike. Even though each of them contains the variable x and y, the arrangement is not exactly the same. So they're not like terms. Example number 6. Here we have a whole string of terms, and our task is to add those together. We do exactly what we've been doing. I usually pick the first term right here and ask, is there anything to which I can add 5x? Are there any other terms like 5x? I search the list. Found one. So I write. I can add the 3x to the 5x. I look further. Found another one. Plus 4x. Now, I look further. Apparently these are the only three terms that involve x. So I go back and I scratch off these three terms that I've considered. I won't look at them anymore. I can add these three together. I look at the next term in line, it's 3y. And I ask, would there be other terms I could add to 3y? I search the list. Here's one. Minus 4y. I continue to search the list. Well, apparently there aren't any other y terms. There were only two of them. Oops. Almost forgot one. I have one right here. Another y term. So I scratch it off. Now I double check, make sure there aren't any others. Okay. Go to the next term. It's a z term. Now notice, this is something you might think about. This is a z. I cross it. You might adopt this notation also if your handwriting isn't any better than mine. Sometimes this saves some confusion. What is this? Is that 2z? Or is that 22? Or is that z times z? If you cross the z, then you eliminate a lot of confusion. Okay, what could I add to 2z? Well, here's a negative 7z. And here's a minus 3z. Again, we're simply observing the rule, you add likes to likes. Now, I've taken care of all the different terms. I've looked at each term here. The only thing I have to do is add. When you add 5x to 3x to 4x, you'll get, when you add 5 plus 3, you'll get 8. 8 plus 4 would be 12. 12x. Now, this leads to something that could cause some confusion. How do you add here? Is it better to add these two together and then add this one? Or should I add these two together and then add this one? From arithmetic, if you're adding 5 and 3 and 4, it doesn't make any difference in what order you add. 5 plus 3 would be 8, plus 4 would be 12. If you take another order, 3 plus 4 would be 7, plus 5, that's still 12. From arithmetic, we know it does not make any difference in which order we add. The same is true here. Add these in any order you wish. 3y added to a minus 4y added to a 2y. 3 added to a minus 4 would be minus 1. Minus 1 added to 2 would be 1. So you can write this as 1y or simply y. Plus 2z added to a minus 7z would be minus 5z. Minus 5z added to a minus 3z would be minus 8z. Okay? So you could write this as 12x plus y plus a minus 8z if you wished, or you could simply write it as 12x plus y minus 8z. Now we'll have more to say about this minus sign in just a moment. Before we do this, we have one more example in addition. Our last example in addition. Here we have a number of terms. Our objective is to add as much of this as we can together. So we look at the first term, 4x to the third power. We search our list for something having the same variable arrangement. Here is one. To this I'm going to add minus 8x to the third power. I continue looking, and apparently there is no other term. Mark those two off. Those two are going to be added together. Turn my attention to the next term, 2x squared y. And I start looking. Now avoid making a mistake right here. Are these two terms alike? They both have x and y involved. They both have exponents of 2 and 1. But this means x times y, and this means x times y times y. Not the same. The arrangement of variables must be the same, and these are not. However, when I look further, I have 6x squared y. Same arrangement as here. So I do have something to which I can add my 2x squared y. I look further, not the same. This means y times x. That's not the same as x times y. So I found two that are alike. These two, I cross them off. I add those two together. Plus, the next term that I encounter is 5xy squared. The only other term that I haven't considered is 10y squared x. Are these two terms alike? Well, back to arithmetic. This variable arrangement means x times y times y. This variable arrangement, y times x. Are they the same? You bet. It doesn't make any difference in what order I multiply. X times y times y, y times y times x. All the same. These are alike. So I can record those two together. Now the only thing I have to do is add. 4 added to a negative 8 would be a negative 4 x to the third power. Plus, adding here, 8 x squared y. Adding here, 15 xy squared or y squared x, whichever you prefer. When I add those together, I get a trinomial, a three-termed expression. Further addition is not possible because these three terms are not alike. Now, if you have learned to add, then subtraction won't be a problem. I'd like you to stop, turn off the tape right now, and practice adding. Practice until you have the technique of adding down pat. Then return to the tape and we'll talk about subtraction. Keep in mind, algebra is arithmetic. In arithmetic, when you want to subtract, if you have two numbers, 359, from this you want to subtract 243. You subtract likes from likes. 3 from 9 would be 6. 4 from 5 would be 1. 2 from 3 would be 1. What we're really saying is 3 groups of 100 plus 5 groups of 10 plus 9 groups of 1 is what this number right here means. From this I want to take 2 groups of 100 plus 4 groups of 10 plus 3 groups of 1. I subtract likes from likes. 3 ones taken away from 9 ones would be 6 ones. 4 tens taken away from 5 tens would leave me with 1 10. 2 100s taken away from 3 100s would leave me with 1 100. And we call that 116. The rule for subtraction is the same. You subtract likes from likes, just like addition. Now, we have some other things in arithmetic that we need to recall. When you dealt with integers, when you were subtracting with sign numbers, 5 minus a negative 3. Do you recall how you were taught to do that? There are various methods, but most of the methods revolve around doing something like this. Change your subtraction problem into an addition problem. Trade your subtraction sign for an addition sign. The cost of that is taking the opposite of this second number. So if this were a negative 3, we would change this to a plus 3. And so we've changed our subtraction problem into an addition problem. 5 plus 3 would be 8. Now, is that the right answer? Well, think back. If you have a very simple subtraction problem like 6 minus 2, the answer to that is 4. Are you sure the answer is 4? To check, we need only add 4 to 2. 4 plus 2 should give us 6. So checking subtraction is a fairly easy task. We simply add. Here we claim the answer is 8. 8 added to negative 3 would be positive 5. So yes, this is the right answer. The gimmick that we used, the algorithm that we used, was this. Change your subtraction sign to an addition sign, take the second number and use its opposite. This was a negative 3, so we used a positive 3. Change the sign on this last number and add. That gives you the answer to your subtraction problem. Let's try one more of this type. We have negative 3 and we want to subtract from that a negative 2. Negative 3. Change this to an addition sign. The cost of changing from subtraction to addition, we've got to change the sign on this second number. This is a negative 2, so this becomes a positive 2. When you add a negative 3 to a positive 2, you'll get a negative 1. To check and see if this is really the answer, negative 1 added to a negative 2 is indeed a negative 3. So this is the right answer. Now, all we have to do is take this knowledge of arithmetic and apply it to algebra. Example number 1 in subtraction. 5x minus 3x. Subtract likes from likes. You have 5 x's, you take 3 of those away. Common sense tells you you're going to get 2x. 2x added to 3x is indeed 5x. If we use our trick, our algorithm, our method for this, it certainly works. We trade this in on addition. This is a positive 3x. We change this to a minus 3x. 5x added to a negative 3x is 2x. All right, example number 2. 15xy minus a negative 3xy. Subtract likes from likes. You want to use the rule. 15xy. We trade this in on addition. This means we have to change the sign on this second number. Make that 3xy. 15xy added to 3xy would be 18xy. I think you can see if you don't add well, then there's not much chance for subtraction. You must be able to add. Is this the correct answer? Is 18xy the answer to this subtraction problem. 18xy added to a negative 3xy. 18 added to a negative 3 is 15. So this is the correct answer. Okay, move to example number 3. Here we have two numbers we want to subtract. Subtract likes from likes. Before we do this, we change our problem to an addition problem. 5x squared plus 2x minus 3. Trade this in on addition. We have to take the second number and change all the signs. This is plus 4x squared. This becomes minus 4x squared. This is plus 3x. It becomes minus 3x. Minus 5 becomes plus 5. Add. Likes to likes. 5x squared, we look through our list, added to a minus 4x squared. We add those two together. 2x added to a negative 3x. We add those two together. Minus 3 added to 5. We add those two together. Add 5x squared added to a negative 4x squared would be 1x squared, or simply x squared. 2x added to a minus 3x would be a minus 1x, or simply minus x. Negative 3 added to a positive 5 would be 2. So we could write this as x squared minus x plus 2. Are we right? Well, it doesn't take much to find out. If I add this to this, I should get what I started with. Let's see. 4x squared added to x squared is 5x squared. So that part's right. 3x added to a minus x would be 2x. That's right. Minus 5 added to a plus 2 is minus 3. So that's right. Now, let me make another comment here. This may not be the way your instructor explains this to you. I'm trying to show you that algebra and arithmetic are one and the same. Someone else may explain this problem to you in a different fashion, but they're saying the same thing. In other words, this is what you might hear. Same problem. 5x squared plus 2x minus 3. From this, I want to subtract 4x squared plus 3x minus 5. Some instructors will tell you to remove the grouping symbols. Take off these parentheses. And here are the rules. If you have a set of parentheses preceded by either no sign or a positive sign, then you may erase those. 5x squared plus 2x minus 3. If you have a set of grouping symbols, parentheses, preceded by a minus sign, to remove those, you must change the sign on each term inside. Remove them. Minus 4x squared minus 3x plus 5. Combine like terms. X squared minus x plus 2. Now that's the same result you had a moment ago. This is simply a different way to view it. Okay, let's move on to our last example. Okay, our last example on subtraction. We have 5xy plus 4x squared y minus 3xy squared minus negative 13yx plus 5x squared y minus 3xy squared. Step 1, change subtraction into addition. That means we change this sign to addition. The signs on each term here will change. This becomes 13yx. Remember, that's the same thing as xy. Minus 5x squared y plus 3xy squared. Add. What's the rule for addition? Likes to likes. 13yx is the same as 13xy. These two, 15xy, 13xy, or yx, are the same. 4x squared y can be added to minus 5x squared y. Minus 3xy squared can be added to plus 3xy squared. We add 28xy minus 1x squared y. Minus 5 added to 4 would be minus 1. Write the 1 as you please. Minus 3 added to 3 is 0. So this gives me 0x squared, or xy squared. When you multiply by 0, you get 0. So this is simply 28xy minus x squared y. Now you could check this just as you've checked your others. Now, what I'd like you to do, when you're through with this tape, the key to your ability to use this later on is practice. Use the problem set that your instructor provides and practice, first of all, adding, and then move on into subtraction. If you'll practice until these things become second nature to you, then you'll be in great shape.